Alright, today we're going to be talking about section 7-2, and we are dividing monomials. There are three main ideas in this section. The very first one, we're going to be focusing on simplifying expressions involving quotients, or as you'll see them, fractions. Second, we will be dealing with exponents of 0. And third, we will be looking at exponents that are negative numbers. So to start off with simplifying expressions, I think the main thing that you need to remember is that you need to find some common factors. Okay, so we'll start off with an example. Let us try 2 to the 5th divided by 2 to the 3rd. Okay, so factors are numbers that you multiply together to make up the product. Okay, so if you have 2 to the 5th, you would actually be multiplying together 2 times 2 times 2 times 2 times 2, 5 times. And 2 to the 3rd would look like 2 times 2 times 2. Okay, just like regular fractions, we can simplify. Okay, and especially if you have one factor in the numerator and one factor in the denominator, you know you can cancel those out. We can cancel these, we can cancel these, and what you have left is 1 times 1 times 1, which is 1, times 2, which is 2, times 2, which is 4. Okay, but let me write this out. This is 2, there are two 2's, so 2 squared over 1 times 1 times 1, which is 1. So 2 squared would give us the answer 4. Okay, so when in doubt, just write it out. Okay, so let's take a look at a second example. If you were to have x to the 3rd, we're throwing in variables now, and y to the 4th divided by x squared and y. What you would have if you would break this out, I'll give you a second to see what you come up with. Okay. Did you get x times x times x times y times y times y times y all over x times y? Okay, if you did, that means you're going to start canceling out. You can cross out these x's, you can cross out these x's, you can cross out these y's, leaving you with, in the numerator, x to the 1st power, there's only 1, and y to the 3rd power. Okay, in the denominator, you're only going to have, well, 1. So that leaves you with x to the 1st times y to the 3rd. Okay, so we're going to stop here and we're going to take a look at what happened when you were dividing. Okay, what happens when you're simplifying expressions with quotients. You have 2 to the 5th divided by 2 to the 3rd. Your answer was 2 to the 2nd. Okay, see if you start recognizing a pattern here. X to the 3rd divided by x to the 2nd. You got x to the 1st. Y to the 4th divided by y to the 1st. You got y to the 3rd. Did you notice the rule? Okay. So what I want to show you now is, let's break out that concept. The concept of quotients of a power. Okay, so when you're dividing two powers with the same base, you're going to just subtract the exponents. Okay, keep in mind here that a has to be a number other than 0. Okay, it has to be an integer other than 0. So let's try, I want you to try using the rule to solve this problem here. Okay, we said that we can just subtract the exponents when the bases are the same. Okay, here the bases are the same, your base is x. So what we're going to do is we're going to subtract the exponents, 7 minus 6. Here the bases are the same, they're both y's, and so we can subtract the exponents. Our answer then will be x to the 7 minus 6, which is 1, and y to the 12 minus 3, which is 9. Okay, you could also just write this as x times y to the 9. Okay, so using the rule is really simple. Just subtract the exponents. Okay, so the very next thing we want to talk about is what happens when you have the power of a quotient. Power of a quotient. Okay, so to find the power of a quotient, you're going to share the exponent with the numerator and the denominator. And I'm going to write, and don't forget the coefficients. Okay, because you have to share that exponents with the coefficients as well. Okay, so taking a look at this example, we always say, when in doubt, write it out. Okay, so this is everything that's encased in the parentheses to the third power. That means everything in the parentheses will be multiplied together 3 times. If I write it out, I would have 1, 2, 3 replicas. Okay, and we're multiplying together. Okay, but yesterday Mrs. Kwan already talked about the rule when you're multiplying. Okay, when you have a power of a power. Okay, so you're going to be sharing that exponent not just with the coefficient but also with every single term, and in this case you're also sharing it with the denominator. So you could either write it out and multiply it out, or you can just share the exponent. You would have 2 to the third power times c to the third power, which is c to the 9th, or d to the third divided by 4 to the third power. Okay, and you would of course simplify that out. 2 to the third power is 2 times 2 times 2, which is 8. C9 d to the third divided by 4 times 4 is 16 times 4. 16 times 4, just making sure, 64. Okay, and we can still simplify because we know that we have common factors here. So let me move this up. Okay, I know that 8 goes into 8 once, 8 goes into 64 8 times. So my final answer, simplified, would be c to the 9, d to the third, all over 8. Okay, so you're sharing that exponent not just with the numerator, but also with the denominator. Okay. All right. So the second concept that we want to address is the concept of zero exponents. Okay, so what happens when your exponent is a 0? Okay, yesterday or earlier we talked about dividing with exponents. So if you have x to the 5th divided by x to the 4th, you subtract the exponents, you got x to the 1st, that's wonderful. But what if you have a situation like this? X to the 5th divided by x to the 5th. Well, technically, the bases are the same. The base is x. You would subtract the exponents, but that's x to the 0. What is the value of x to the 0? Okay, we're going to go back to this. If we were in doubt, we would be writing it out. We would be writing x times x times x times x times x all over x times x times x times x times x. And if we were to simplify this, we'd be like, well, we have common factors, lots of common factors. Lots of common factors. We'd have 1 times 1 times 1 times 1 times 1, which is 1, all over 1 times 1 times 1 times 1 times 1, which is 1. X to the 0 then, x to the 0 is 1. Okay, let's try this. What happens here? Okay, if you worked it out, you would have gotten, this is 4 to the 0, which is the same thing as 1. Are you starting to see a pattern? Okay. A to the 0 then, same concept, would be also 1. Okay. If you have a situation like D, any exponent to the 0 power looks like, we can follow that pattern, is going to be 1. Okay. So the key is, for, oops, let me get this, key concept, you want to write down the 0 power rule. Any non-zero number raised to the 0 power is 1. Okay. The very last idea we want to talk about is what happens when you have negative exponents. Okay. So we had talked about the situation with positive exponents, but what if this problem were reversed? What if you had x divided by x to the 5th? Okay. This here, there's an exponent, you just don't see it, so it's a 1. If we were to write it out, we'd have the same base, so we can subtract the exponents. We would get x to the 1 minus 5 is a negative 4. My goodness, what is that going to look like? Well, when in doubt, we can just write it out. We have here x divided by x times x times x times x times x. Okay, we can simplify because we have common factors. I can cross that out. I can cross this one out. Goes in once, goes in once. So in the numerator we'll have 1. In our denominator we'll have 1, 2, 3, 4. X to the 4th. Okay, so that means that x to the negative 4 is the same as 1 over x to the 4th. Okay, so what do you notice about x to the negative 4? X to the negative 4 looks like it is the reciprocal of x to the 4th. Okay, so that is the exact rule when you have negative exponents. If you have a to a negative power, any number to a negative power, that is equivalent to the reciprocal of that number to the positive exponent. Okay, so all you're doing is you're taking the reciprocal, making that exponent positive. Okay, let's do some examples and apply that rule. Okay, you have example A, and we'll run through this together. This is b, same base. Let's subtract the exponents. Okay, so b to the negative 8. So here, b to the negative 8 will be the reciprocal with the positive exponent. Okay. Try this one. You should get 1 over x squared. Okay. And one last one for you to try. This one's a little bit more difficult, but we have same base. You have p to the 3rd minus 5, because that's the same base here. You have q to the negative 5 minus a negative 4. And you also have, you don't have any r's to the 0 on top, right? Because this is kind of like multiplying by 1. You can say r to the 0 minus a negative 8. Okay, so let's simplify this. You'll have p to the negative 2, q to the negative 1, and r to the positive 8. Okay, and we're going to need to do a little bit more work with this. Okay, if you're taking a look at this, p to the negative 2 we said is 1 over p squared. q to the -1 is 1 over q to the first. And r to the 8 is, well, just r to the 8. And if we want to make it a fraction, we could put it over 1, multiply it straight across. We have r to the 8 all over p squared q. Okay, this is the most simplified version. Okay. All right. So let's see what we need to do. Like you have to take care of textbook, checking your understanding on page 370, numbers 2, 5, 8, and 11. Bring that to class tomorrow and we will check it over.